Welcome to Math with Mr. J.
In this video, I'm going to cover how to solve two-step equations. We will go through 4 introductory examples, examples with negatives, and examples where we have 2 terms in the numerator. So one side of the equation will be set up in fractional form. Taking a look at these different types of equations will set us up for success as far as solving two-step equations and solving equations in general. Now, when we solve two-step equations, we want to isolate the variable, just like when we solve one-step equations. So we want to get the variable by itself. And we do that by using inverse operations, opposite operations. Basically, we want to use inverse operations to undo the operations on the side of the equation with the variable. And this will isolate the variable. And remember, whatever we do to one side of the equation, we must do to the other. We have to keep everything balanced and equivalent. Let's jump into our examples and see what this looks like. Starting with number 1, where we have 3x plus 10 equals 28. So we need to solve this equation. We need to figure out what x equals. So 3 times what plus 10 equals 28. Let's isolate that variable of x. So we need to undo the operations on the side of the equation with that variable x. And we're going to go in the reverse order of operations, so to speak, in order to do that. We have multiplication and addition. So reverse order of operations here, we need to undo the addition first. What's the inverse, the opposite of addition? Well, subtraction. So let's subtract 10 from the left side of the equation. Whatever we do to one side of the equation, we must do to the other. So subtract 10 from the right side as well. Now on the left side of the equation, we are adding 10 and subtracting 10. So these 10s cancel each other out. So we are left with 3x equals, and then on the right side of the equation, we have 28 minus 10, which gives us 18. So now we have 3x equals 18. We are multiplying x by 3, so we need to undo that. We need the inverse operation here in order to isolate x. The inverse operation of multiplication is division, so let's divide the left side of the equation by 3. Whatever we do to one side, we must do to the other, so divide the right side by 3 as well. On the left side of the equation, we are multiplying by 3 and dividing by 3, so these 3's cancel each other out. Now our variable, x, is isolated. So we have x equals, and then on the right side of the equation, 18 divided by 3 is 6. So x equals 6, and that's our solution. Now, one last thing we can do, we can always check to see if we are correct. And we do that by plugging in what we got and seeing if it works. So for example, let's plug in 6 for x and see if it works. So we can come to the side here. 3 times 6 plus 10 equals 28. So we need to multiply first. 3 times 6 is 18, so we have 18 plus 10. 18 plus 10 is 28, so we are correct. X equals 6. Let's move on to number 2, where we have 9y minus 12 equals 15. So 9 times what minus 12 equals 15. We need to isolate that variable of y. We need to undo the operations on that side of the equation. We have multiplication and subtraction. So we need to go in the reverse order of operations in order to undo everything here. We need to undo the subtraction first. So what's the inverse operation of subtraction? Well, addition. So let's add 12 to the left side of the equation. Whatever we do to one side, we must do to the other, so add 12 to the right side as well. On the left side, we are subtracting 12 and adding 12, so these 12s cancel each other out, so we have 9y equals, and then on the right side of the equation, 15 plus 12 gives us 27. So now we have 9y equals 27. So we're multiplying y by 9, and we need to undo that multiplication by using the inverse operation. What's the inverse operation of multiplication? Well, division. So let's divide the left side by 9. Whatever we do to one side, we must do to the other, so divide the right side by 9 as well. On the left side, we are multiplying by 9 and dividing by 9. So these 9s cancel each other out, and our variable, y, is now isolated. So we have y equals, and then on the right side of the equation, we have 27 divided by 9, which gives us 3. So y equals 3. And that's our solution. Now let's plug it in and see if we are correct. So plug in 3 for y. So 9 times 3 minus 12 equals 15. So we start with multiplication. 9 times 3 is 27. 27 minus 12 is 15. So we are correct. Y equals 3. Let's move on to numbers 3 and 4. So here are numbers 3 and 4. Let's jump into number 3, where we have d divided by 8 plus 32 equals 41. So we need to isolate that variable of d using inverse operations, and we need to go in the reverse order of operations. We need to undo the addition first. So what's the inverse operation of addition? Well, subtraction. So let's subtract 32 from the left side of the equation. Whatever we do to one side, we must do to the other. So subtract 32 from the right side as well. Now on the left side of the equation, we are adding 32 and subtracting 32. So these 32s cancel each other out. So we have d divided by 8 equals, and then on the right side of the equation, we have 41 minus 32. That gives us 9. So we have d divided by 8 equals 9. So let's continue to look to isolate that variable of d. So d is being divided by 8. What's the inverse operation, the opposite of division? Well, multiplication. So let's multiply the left side by 8. Whatever we do to one side, we must do to the other. So multiply the right side by 8 as well. Now on the left side, we are dividing by 8 and multiplying by 8. These 8s cancel each other out. So d is now isolated. D equals, and then on the right side, 9 times 8 gives us 72. So d equals 72. That's our solution. And let's check that by plugging 72 in for d. So we have 72 divided by 8 plus 32 equals 41. 72 divided by 8 is 9. So we have 9 plus 32, and that gives us 41. So we are correct. D equals 72. Lastly, let's move on to number 4, where we have 2 equals h divided by 5 minus 9. Now for number 4, the variable is on the right side of the equation. So a little bit of a different look here, but we use the same exact process. So this doesn't change anything. So we need to isolate that variable of h. So h is being divided by 5, and then we are subtracting 9. So let's undo that subtraction first. What's the inverse operation of subtraction? Well, addition. So let's add 9 to the right side of the equation. That means we need to add 9 to the left side as well. Now, on the right side of the equation, we are subtracting 9 and adding 9. So those 9s cancel each other out. So we have h divided by 5 equals, and then on the left side, 2 plus 9 gives us 11. So h divided by 5 equals 11. So we are dividing h by 5. What's the inverse operation of division? Well, multiplication. So let's multiply the right side by 5. That means we need to multiply the left side by 5 as well. Now, on the right side of the equation, we are dividing by 5 and multiplying by 5. So these 5s cancel each other out. And h is now isolated. So we have h equals, and then on the left side of the equation, 5 times 11 gives us 55. So h equals 55. So that's our solution. And let's check it by plugging 55 in for h. So 2 equals 55 divided by 5 minus 9. 55 divided by 5 is 11, and 11 minus 9 is 2, so we are correct. H equals 55. So there are our 4 introductory examples. Let's move on to a couple of examples involving negatives. Here are our examples involving negatives. Let's jump into number 1, where we have negative 2w plus 6 equals 14. So negative 2 times what plus 6 equals 14. We need to isolate that variable of w by using inverse operations, and we will go in the reverse order of operations. So we need to undo the addition first. What's the inverse operation of addition? Subtraction. So we need to subtract 6 from the left side of the equation. Whatever we do to one side of the equation, we must do to the other. So subtract 6 from the right side as well. Now on the left side of the equation, we are adding 6 and subtracting 6. So these 6's cancel each other out. So we have negative 2w equals, and then on the right side of the equation, 14 minus 6. That gives us 8. So we have negative 2w equals 8 now. So we are multiplying w by negative 2. We need to undo that multiplication. What's the inverse operation of multiplication? Well, division. So let's divide the left side of the equation by negative 2. Whatever we do to one side, we must do to the other. So divide the right side by negative 2 as well. Now on the left side of the equation, we are multiplying by negative 2 and dividing by negative 2. So these negative 2's cancel each other out. W is now isolated. So we have W equals, and then on the right side of the equation, we have 8 divided by negative 2. So we have a positive 8 divided by a negative 2. When we divide a positive by a negative, we get a negative. So 8 divided by negative 2 gives us negative 4. So we need to be careful there when we have negatives involved. W equals negative 4. And that's our solution. Now we can check this by plugging negative 4 in for w and seeing if it works. So let's do that. So we have negative 2, let's come to the side here, times negative 4 plus 6 equals 14. All right, let's start with multiplication. So we have negative 2 times negative 4. A negative times a negative equals a positive. So this gives us 8. And then we have 8 plus 6, which is 14. So we are correct. w equals -4. Let's move on to number 2, where we have -10 on the left side of the equation equals, and then on the right side we have m divided by 6 minus 7. So what divided by 6 minus 7 equals -10? So we need to look to isolate that variable of m. So taking a look at that side of the equation, we need to undo the subtraction first. So we have -7. What's the inverse operation of subtraction? Well, addition. So let's add 7 to the right side of the equation. Whatever we do to one side, we must do to the other. Now, on the right side of the equation, we are subtracting 7 and adding 7. So these 7s cancel each other out. So now we have m divided by 6 equals, and then on the left side of the equation, we have -10 plus 7. So we are starting at -10 and we are adding a positive 7. So we are increasing in value by 7. That gives us -3. So now we have m divided by 6 equals -3. So let's isolate that variable of m. We are dividing m by 6. So what's the inverse operation of division? Well, multiplication. So let's multiply that side of the equation by 6. Whatever we do to one side of the equation, we must do to the other. So multiply the left side by 6 as well. Now, on the right side of the equation, we are dividing by 6 and multiplying by 6. So these 6's cancel each other out. M is now isolated. So we have m equals, and then on the left side of the equation, 6 times -3, well, we have a positive times a negative. A positive times a negative gives us a negative. So 6 times -3 gives us -18. So m equals -18. And that's our solution. Let's check it by plugging -18 in for m. So we have -10 equals -18 divided by 6 minus 7. Let's start with division. So we have -18 divided by 6. A negative divided by a positive equals a negative. So that gives us -3. And now we have -3 minus 7. Now there are a couple different ways to think through this. So we are starting at -3 and subtracting 7. So we are decreasing in value by 7. That gives us -10. Another way to think through this, whenever we have subtraction, we can add the opposite, and that will give us the correct answer as well. So add the opposite. So we have -3 plus -7. That gives us -10 as well. So we are correct. M equals -18. So there you have it. There's how to solve two-step equations involving negatives. Just keep in mind, be careful when working with those negatives. And if you need more help or examples with addition, subtraction, multiplication, or division involving negatives, I added links to those videos down in the description. So there are our examples involving negatives. Let's move on to equations with two terms in the numerator. Here are our examples with two terms in the numerator. So basically, one side of the equation is set up in fractional form. Let's jump into number 1, where we have x plus 7 as our numerator and 3 as our denominator equals 5. So something plus 7 divided by 3 equals 5. Remember, when we are set up in fractional form, we have that fraction bar. That means we are dividing. Now, we're not just dividing x by 3 or 7 by 3. We can think of that fraction bar as a grouping symbol. X plus 7 is being divided by 3. We can even put parentheses here to group the numerator. Again, that fraction bar acts as a grouping symbol, and we divide the numerator by the denominator. Now we need to isolate that variable of x by using inverse operations. And we're going to go in the reverse order of operations. We have addition and division here. But the addition is grouped, it's in parentheses, and then we have division. We need to undo the division first. So we can think of this as getting rid of the fraction first. So what's the inverse operation of division? Well, multiplication. So let's multiply the left side of the equation by 3. Whatever we do to one side, we must do to the other. So multiply the right side by 3 as well. Now on the left side, we are dividing by 3 and multiplying by 3. So these 3's cancel each other out. Now we just have x plus 7 on the left side equals, and then on the right side, 5 times 3 gives us 15. And now we have x plus 7 equals 15. So we are adding 7 to x. We need to undo that addition in order to isolate the variable. What's the inverse operation of addition? Well, subtraction. So let's subtract 7 from the left side. Whatever we do to one side, we must do to the other. So subtract 7 from the right side as well. On the left side of the equation, we are adding 7 and subtracting 7. So these 7's cancel each other out. X is now isolated. So we have x equals, and then on the right side, 15 minus 7 gives us 8. X equals 8. And that's our solution. Now we can check that by plugging 8 in for x and seeing if it works. So let's come to the side. We have 8 plus 7 divided by 3 equals 5. So let's start with our numerator, 8 plus 7. Remember, that fraction bar acts as a grouping symbol, so we will work through the numerator and then divide. 8 plus 7 is 15. So we have 15 divided by 3. That does give us 5, so we are correct. X equals 8. Let's move on to number 2, where we have 2 on the left side of the equation equals, and then on the right side of the equation, a minus 15 divided by 12. We have subtraction and division, but the subtraction is grouped in the numerator, and we can even use parentheses to help us picture that. We don't have to write those parentheses, but it is an option. So we need to undo the division first. We need to get rid of the fraction. So what's the inverse operation of division? Well, multiplication. So let's multiply the right side by 12. Whatever we do to one side, we must do to the other. So multiply the left side by 12 as well. On the right side, we are dividing by 12 and multiplying by 12. These 12s cancel each other out. So now we just have a minus 15 equals, and then on the left side, 12 times 2 gives us 24. So a minus 15 equals 24. We are subtracting 15 from a, so we need to undo that subtraction. What's the inverse operation of subtraction? Well, addition. So let's add 15 to the right side. Whatever we do to one side, we must do to the other. So add 15 to the left side as well. On the right side, we are subtracting 15 and adding 15. So the 15s cancel each other out. A is now isolated. So we have a equals, and then on the left side, 24 plus 15 gives us 39. So a equals 39. That's our solution. And we can check it by plugging 39 in for a. So let's come to the side here. 2 equals 39 minus 15 divided by 12. Let's start with the numerator. So we have 39 minus 15. That gives us 24. And now we have 24 divided by 12, which does give us 2. So we are correct. a equals 39. So there you have it. There's how to solve two-step equations. I hope that helped. Thanks so much for watching. Until next time, peace.